Right, and I think we are live. All right, hey everyone, FusedMan coming at you, and welcome back to the Fusion Ed weekly live stream. And if you're new to the channel, welcome. This is basically, think of this kind of like VR office hours, where I'm just going to be going over a topic. Today it's going to be tilt brush. And if you have questions about anything, you can ask it in the chat, and I'll be looking at it occasionally. My partner Abdo might be online as well, and going through the chat and taking a look. So yeah, literally ask anything about what we're going to be doing, or like anything that you have like VR related at all, and we'll be happy to talk about that. So, but yeah, other than that, going to start talking about tilt brush. So that's what I have open right now, and I just kind of want to show like what are the basics of kind of what we want to implement today. So I've set up this kind of spectator view, which I think is a really neat feature. And so yeah, if you haven't seen tilt brush before, here it is. I got my two hand controllers that are positionally tracked in my headset, and I got a bunch of different options that are controlled on my left hand here that I'm waving around. And so I can literally just go ahead and draw in 3D space with my right controller. So like, I just have to write backwards for you guys. I think something like this, I think should show up normally to you guys. And then I can just control my options here. And so basically what I'm going to try and implement, and in prepping for this, I kind of realized there's actually a lot, so I'm going to try and break it down as much as possible and see how far we get. But in summary, we're basically going to try and build a system where we can actually just use these controllers, draw lines in 3D space, change the materials, change the colors, create something very simple as just a starting point. And then we can add a bunch of new mechanics. When I was going through the Reddit this morning, I saw like someone asked like if we could do teleportation in here. And like, you can't in tilt brush, but we could, since we're building this from scratch, we can add that. So we're going to be playing around with a bunch of different things, see how far we get. And yeah, if you have questions, then yeah, just shoot them in the chat and we'll take a look at them. Or it worked out really well last time where people would ask and we wouldn't necessarily get to it, and other people could answer. So if that works out this time, that would be awesome too. But I'm going to go ahead and close tilt brush right now. Go ahead and close that. And we're just going to literally start from scratch. So we're going to open up Unity whenever it decides to open. And create a new project. Let's call this, I don't know, custom tilt brush. I'm going to go ahead and save that to the desktop. And there we go. This is what happens when you open up Unity. You get your nice blank project here. And because we're using the Vive, we're going to actually have to go ahead and import SteamVR. So if we go to the asset store, so the asset store is where you can get a bunch of cool plugins and scripts and all of that good stuff. Just to quickly get that into your application. So I'm going to go ahead and import the SteamVR plugin. So that's normally a download button, but if that's your first time, but if you've already downloaded it, you can just get a free import. And once we have that imported, we can go ahead and close the asset store for now. And then go ahead and click. These are all just like a bunch of recommended settings that SteamVR requires. So we're just gonna quickly click through all of that, just like we did last time in the hello to SteamVR. And so I think they recently added a new requirement or new recommended tool, which is using gamma correction as opposed to linear lighting. And that just kind of gives a different feel to the scene, and it's specifically, I think, a little better for VR. I honestly haven't looked too much into the details why, but I can probably look that up a little later and we can find out. But yeah, so that's kind of the reason why the scene slightly changed color. If we like did want to like, not, yeah, it's here. If we did, actually it's linear. But yeah, if we went into the player settings, you can just check and make sure that like this is the actual player setting. So like the two options should be linear and gamma. Um, so like yeah. So sorry, I think I said that backwards. So normally it is gamma, but generally for VR, I think they want it set to linear. And of course now it doesn't change back to that awkward little color. But yeah, so now we have basic scene, and if we wanna, let's just quickly make sure that everything's working. So I'm just gonna go into SteamVR's folder, go into extras, and then go to test throw. So that's each of these are like scene files that control like basically a scene or like a view into the application. So this is the SteamVR plugin right here, and we're just gonna go and quickly check that it's working. So in this specific scene, you can go ahead and throw a bunch of different objects around. That's weird, but there we go. This controller seems a little off. I don't know why. That's odd. Feels like it's like rotating around an object. It's not actually on me. It's strange. This controller seems fine. I can actually throw stuff around. It might be just be something in the code that they changed. So, yep, seems like everything's working. I'm just gonna quickly check and make sure there wasn't anything wrong with the right controller. Like it's not. I think it should be fine. Yeah, these settings all look the same. I'm not. See if that was happening. That one looks fine. Okay, that's strange. I don't know. So if I 0. Whoops. So it wasn't happening in Tilt Brush. That's like a. I don't know why. Sometimes with these SteamVR plugins, they tend to, every time they do an update, they tend to introduce a new bug. It's kind of strange. But I'm going to ignore that for now because it's not terribly important. The more important thing that I'm gonna start out with is going ahead and creating a new scene. And so just to get started, what we have to do is drag and drop our camera rig. So that's in our SteamVR prefabs folder. Drag and drop that into the scene. And that's exactly the same thing that we were seeing in the other scene. And so that lets us use the Vive. And so once we have that in, the first thing that probably just to kind of start off easy, the first thing we'll probably want to do is how do you actually draw a basic line in 3D space? So we're first going to do it the somewhat the simplest way possible. And then once we do that, I'm going to probably notice a few bugs. And those bugs, to be honest, are a little tricky. Is what I realized in prepping for this was it's a little tricky to actually fix those. But I have a script for that, and let me know in the chat if you want to see how that one actually works. I'll probably actually use Tilt Brush to explain how it works, because just to give you guys an intuitive sense. But like, basically what we're going to end up doing is rewriting some of the built-in stuff that Unity provides, and that'll take a lot of time that I think would be better spent elsewhere. So, but like let's first start with the basics. So this is going to be, I'm going to create a new C# script, call it draw line manager. And so this is going to be basically exactly what it is. It's a script that's going to manage our ability to draw the line. So I'm going to actually go ahead and open up, because I never remember the syntax for some of this stuff. So I'm going to go ahead and open up the throwing one. Yeah, it should be in here. Yep, exactly. And we're just going to go ahead and, so for the throwing one, this is how they choose to get access to your hand controller. And so we're going to go ahead and copy that into the update method, get rid of some of the code that we don't need, and we're going to actually use the type checking that C# provides, because kind of silly not to use type checking when you have a type checking system. And I'm going to go ahead and get rid of that. So just to kind of quickly break down what these two lines of code are doing. The first line of code is asking for, it's like a static method that asks for your input, and then it asks for whatever your tracked object's index is. And so we'll need to provide that because that's currently not set up right now. And then this one is just checking. So update is called every time we draw the scene, and the if statement here just checks to see if we've pulled the trigger, basically. So on the controller here, if we pull this button, that if statement checks for that. So what we want to do is go ahead and get access to a tracked object. So let's go back to the test scene, and I'm going to go ahead and copy that. And so they don't have it public for in their instance here. They actually set it in the awake method, which is like whenever the script is first created, awake is the method that's called. So, but what we're going to do is actually make it a public variable. And just to make sure that everything's working, I'll go ahead and create a simple log that says got here. So hopefully, assuming I didn't mess anything up in those few lines of code, I'm just going to put this at 0, and we're going to, so like everything in Unity is component based, so we just, if we have a script, we can drag it onto each object that is in our scene. And yeah, so I just drew the draw line manager into the inspector, and we can go ahead and we just got to make sure. So we're going to drag out. Yeah, we'll drag the right one. Whoops. Drag the right controller into here. So that tracked object that we were building in the script now comes out as a public variable that we can access within the editor itself. So I'm just gonna, I literally just dragged whichever controller I wanted as the tracked object and put that right there. So now let's actually change the name of this guy to Draw Line Manager. And assuming this is the right controller, these turned off. Alright, so I think that is the left controller. Which one is the right controller? The right controller is this guy. And it is not. Drawing. Might not. You're in the scene. Okay. Oh, it is. It's just. Okay. I actually just need to go ahead and get rid of the main camera because it's filling up. Yep, there we go. So now in the console, that's where all our messages are, and I can pull the trigger, and we get a bunch of got here's. So we know that's working. So now, once we have that, what we want to do is actually go ahead and, so whenever we pull the trigger, we want to basically start drawing a line. So the way, and actually I can probably show this in the editor first. So the way that we're going to prototype drawing a line is going here and create this at 0, 0, 0. Not that it actually matters, but we can add a component, and that is a line renderer. And so just like it says, this is a line render. It's a little wide, but we can change a bunch of different properties as far as like the position, start width, end width. So if we want this to be tinier, we can do that, and now it looks more like a line. We can change how long it is, or like we can add more positions along the way. So like say for example, we wanted it to go up in the Y direction, and kind of create like a triangle. We can do all of that really easily just by changing everything in here. We don't actually even need any coin. What's the point of recreating this? Are you going to make it open source? We can. I mean, the point right now really is just to kind of learn as we go. Like take a project, and then learn the basics kind of Unity, learn the basics of creating like an actual project that a lot of people really like. Let's see what else. And also, I guess like one of the things I've noticed like with Tilt Brush and like is like there are definitely a lot of features I want to add. So like I said at the beginning, for example, so some people wanted teleportation of Tilt Brush, but unless the team at Tilt Brush actually does that, like we're not going to actually have anything, or we're not going to be able to add anything like that. The other things, I think I'm going to try and get to this in like a future tutorial, but it's basically creating like a way for like other people to like view what you're doing as you're like creating your creation, in a networked sense. So like for example, imagine like you're drawing in Tilt Brush, and then you have an audience of people, say on Google Cardboard, that can actually watch what you're doing. So basically, I'm building this out in a way that allows us to have full control over exactly what's going on. So yeah, that's just kind of the long answer of what we're trying to do here. Yeah, let me know if that answers the question, or like if you would want more, or want to know more. So Selenium 5 would be available. At the moment, wasn't planning on it, but if there's enough demand for it, then I can probably provide some of the scripts. Yeah, cool. So now, so that's the basics of a line render. I'm gonna go ahead and actually just kind of get rid of this object because we don't want a random triangle in the scene. And so we're gonna go ahead and actually create it in code. So the way we do that is we create a game object within the scene. I'm just gonna call it Go. And to create a new game object, just like if you're familiar with Java, like it's just creating the basic object with a constructor. And so we create that, and then we're going to go ahead and add a component to it. And this component is going to be the line render. And so we now have added a line render to it. I'm going to actually go ahead and create a private instance variable here. We'll call this curline. And we're going to assign that. So when we add the component, we're going to assign that to curline. So that's basically just keeping a reference for us. So like when we go through this update loop multiple times, we can go ahead and just save it every time we create a new object. And that's pretty much the basics of that. And now we're also going to want to so now once we have that, we're going to want to make sure that every time we're holding the trigger down, we actually go ahead and add more points to the line that we're creating. So to do that, I'm going to go ahead and call get touch. So get touch is basically I'm actually holding down the trigger. And so every time we do that, now that we have our instance or our pointer to the instance, we can go ahead and add our set position. I want to call set position. So if we can take a look here at what the parameters are. It's the index and then the position. So the index is going to be where on our list of points we want to actually go ahead and place or draw that specific point. So when I added the three points before, the first point was a 0 index, second point was 1 index, and third point was 2 index. So that's just telling it which index to go to, and then the other one is the actual position. So first, for now, we're just going to ignore the index. We'll get back to it in just a second. But to go ahead and get the position, what we can do is call device.transform. So transform contains all of the position and rotation data. And so we can just call device.transform.pos. And that's the 3D position of our controller at any point in time. So once we have that, we can now actually go ahead and make sure we're always setting the index correctly. So for that, we're going to go ahead and make sure we have a counter set up. So create int num clicks equals 0. I also want to make that private. And let's see. So whenever we pull the trigger down, we just have to make sure we set num clicks to 0. And otherwise, as long as we're holding it here, we want to go ahead and set just increment num clicks. And then we can actually just go ahead and put num clicks as our index. So as we continually build up our line, we keep on setting the index. I'm gonna go, well, here, let's see what this does there. If I don't expect anyone to actually know this. I only found this out by doing things with line renderers, but so there we go. Not that. All right, there we go. There we go. And I think this is the right controller. Yeah. All right. So we got a bunch of errors. And so we see, if we were just looking at the errors, it's like set position index out of bounds. And so the reason for that actually is because if you noticed when so if we go back to just having an empty object here and line render, this position, the size was set to 2. And so actually what ended up happening is I set the first 2 and then that was it. So we actually have to keep updating the size of our line renderer each time we add a new point. So to do that in code, we're just gonna go ahead and go to curl line And then, let's see, set vertex count. So for set vertex count, we want to set it to num clicks plus 1. So that's just making sure that we keep continually adding the number of vertices we want each time we add a new point to it. Obviously, like if you want to optimize this a bit further, you can do predictive allocation, where that just basically means you like allocate, say 100 points, and then once you reach 100, you allocate for 200, and you could keep incrementally doing that. But just kind of for simplicity, we're just going to go ahead and do set vertex count here, just to do it every time. And so now, let's see if I forgot any other errors that might come up. And all right, so cool. Looks like we drew some things. They are over there. Let me actually go ahead and try it out in VR. See what this is looking like. So this one, position is, where's my other controller? There we go. These are trapped right. But why is it all the way over there? That's strange. Okay, that was interesting. Let's see. Did I forget something? So position is set properly. We'll set it to the device's transform.position. Let me go ahead and double check really quickly that I didn't forget a step, because that should have actually aligned it to exactly where the device was. Tracked object. Oh, okay. So that might be okay. I think that's the local position. So there's a. It's not the global position. Okay, that explains it. So if we go to this, so the difference there. So local position versus global position is, and this actually might have worked just fine had these values been set to 0. But basically what that means is, so local position is relative to its parent, and global position is based on this whole entire world here. So by local position, it's basically saying like what's our space within this kind of cube right here, or it's more of a rectangle. Yeah, I guess this rectangle, but then when we actually set it in the code, this set position is the global position in like the whole world space. So there was like a mismatch there. So now if I try it out, yeah, so it's huge, but now it's at the exact position of where our controller is in 3D space, which is exactly what we want. Sweet. So yeah, so that's drawing a line, and now obviously that line is huge, so we can go ahead actually and, again, like I kind of showed before, in the editor, we can encode, go ahead and set the width. So I think we want this super small, because right now it's ginormous. I'm just going to go ahead and set that width. So now hopefully, once it runs, yep, you can see it here. There we go. So we're actually now painting in 3D space. And if I actually get up, so I can walk around, draw it here, I can draw it here, I can draw it here, I can draw it pretty much anywhere in space. And that's just just getting the very basic setup. But as with anything built in, we don't have a lot of control over a bunch of things that are happening with this. And the primary thing, and I might actually go into, no, I'll show it here. Actually, can you see it in the, here, let me zoom in a little bit. I don't think you'll be able to see, yeah. Well, you'll see it in the editor. So if I'm moving around within the editor, you'll notice that the lines are always looking at wherever I'm looking. And that's happening in VR as well. So as I move around, these lines are always like rotating to face exactly where I'm looking. And it's an effect called billboarding. And it isn't exactly the way Tilt Brush works. So the way Tilt Brush actually works is, and yeah, I think I'm going to actually go ahead and jump into Tilt Brush real fast to show you guys. I'll go ahead and close that and launch Tilt Brush here. Go. And grab my controllers. But the way Tilt Brush works is whenever I draw a line, I'll be able to walk around it and move it up a little faster. All right, there we go. So yeah, I'm just going to draw this line, and so this side here is flat, and like very thin, and you might be able to see it if I switch the texture out to like something a bit bigger, for example, paper. So here we have a nice the flat side. If I look at it from here, it's very sharp. It looks like a piece of paper, and it's also painted on the other side. So this effect is very different than what we're getting in the line renderer, because the line renderer is doing is actually it takes this piece of paper and then always rotating it to make it look at me. And yeah, so to be honest, I mean the tilt brush effect is really a lot cleaner than the line renderer. So but we're gonna fix that. And yes, I mean, that's mostly what these live streams are about. Yeah, it's primarily education. So yeah, so I'm gonna go ahead and close Tilt Brush. But the point I wanted to make there is we don't want that billboarding effect, because it does look a little weird outside of in VR. So I'm gonna go ahead and minimize. Actually, no. I'm gonna go open up Unity, and so I wrote a script that actually solves that. And instead of me spending a lot of time, the whole stream, trying to rewrite it, I figure I will open it up and then we can talk about what's going on. It's what was it? Unity alternatives to line renderer. So you can get, let's see if I can find it here. I think it's this guy. Yeah, it's this guy. So if you scroll down to, where does he give a link to it? Yeah, so if you can get the kind of a starting template with the source code. I've kind of edited it heavily to make it work with Tilt Brush, and I'm going to show you kind of the edits I made. But like, yeah, if you want basically kind of where this code is based from, it's this blog. So if you Googled Unity alternatives to line renderer, you'll find it's this Everyday 3D website, where you can find a link to some of the starter code for that. And yeah, even getting that starter code took me a while to find. I should go ahead and delete this line renderer here. So let's see, I want to open up, and go ahead and open up the graphics line renderer, and talk about performance. With the current way you show allow a full picture with greater than 90 frames per second. Yeah, actually, I mean, yeah, So the line renderer is actually not as optimized for drawing the lines. It's still pretty good, but not like if you read through that blog, it's not the most optimized thing in the world. The thing that is written here as part of what I've called the graphics line renderer, it should actually now be renamed as the mesh line renderer. But this one should be a lot more optimized because we're actually building a mesh, and then it'll become static in our scene. With the line renderer, because of like the billboarding effects and stuff like that, it still is. It's not the most optimal, but it'll actually get you pretty close. Like when I draw like hundreds of lines, I'm still hitting around like 100, 110 FPS within even the Unity editor. That obviously gets optimized once you're outside of Unity. So yeah, that kind of basically, as far as performance, yeah, not the best. In summary, it's not the best, but still pretty good. And yeah, you can always get better. Like that blog post, like they even have like a little OpenGL code to write some stuff. So yeah, so let's talk about this thing. So it's called I called it the graphics line renderer. Um, but it's basically building a mesh with a bunch of different points. And yeah, I'm actually going to go back into Tilt Brush to explain what's going on, because I think that Tilt Brush is I actually ended up using Tilt Brush to help me in part of the coding process for this. So the way it works is everything. It's basically what we call procedurally building a mesh. So we're building the mesh as we go, and the way every mesh in 3D graphics is built is with vertices and triangles. So that's exactly what we're doing here. So yeah, we're good. So basically, what happens when I in Tilt Brush when I make this line, it's basically sampling a bunch of different points along the line. So you have a point here. They'll obviously spaced a lot closer, but just to kind of give you the idea of what's going on, you have a bunch of different points on this line, and what we want to do is actually go ahead and draw a bunch of squares. Obviously, this one is specifically a lot smaller, but we're just adding a bunch of different squares to basically visualize a line. And so what are squares made of? You can draw them as two triangles, and that's how you input into any 3D engine for developing like with 3D asset creations like Blender or Maya or anything like that. The way you'll basically do is you define vertices, you'll define triangles, and those triangles then just get rendered out in 3D space. So like when I draw something out here, I don't know, like a cube. Oh, that was a horrible cube. You get the point. But like all these vertices get mapped, and then we draw triangles to build it. So now, if we so this is exactly the same concept that we want to use when we're building out our line. So if I have, let me go ahead and erase that just to get some space. But say I have point here, point here. We want, so we know that we're going to call this our start one. We're going to call this the end, and that. So we know we want a rectangle or a quad that's basically encompassing these 2 points. And so the way we're going to do that is to define what this actual quad should be. Is we're going to, since we know this is the start and end, we know that this is the direction we're going in. That's kind of our velocity vector. And we want, if I'm drawing like this, I want whatever that quad is to come out and face me. Let me pick another color. Let me go ahead and erase that. Where's the erasing? There we go. Get rid of that. And change the color like a reddish. There we go. So we want a normal facing out that way. Normal is like perpendicular to the plane. So that's actually facing me. And then let's pick another color for the quad. So we want a quad like this. So this is the triangle. So we basically give them these 2 points, and we know which one's the start and end. We want to calculate this normal. If we have like a width that we want to provide, we can use that as well. And then once we have this normal, we want to calculate these 4 points. That makes up our quad. And once we have these 4 points in that pre-defined order, we want to go ahead and add those and call those vertices. We want to then go ahead and define these 2 triangles. And we're actually also going to want to define it for the backside. So each triangle is, because there's a normal associated with it, they will face towards me and be filled in on, say, this side right here. But we also want to, from looking at it from this side, I will also, like, just like in Tilt Brush, when I draw paper, I can see it on this side and see it on this side. We want to also be able to, what's the light? Fill in that side. So we're going to create vertices for the front and back, and we're going to also create triangles for the front and back. And that's basically what the code is going to do. So yeah, Tilt Brush can be used as an educational app. That's more than just drawing, which is, I think, really cool. Go ahead and close that. And so yeah, hopefully that gives you a sense of what the code is actually doing. And so yeah, let's just kind of start from the top and then walk our way down. So the first thing we do is we define a material. I call it LMAT for like line material. We have a bunch of instance variables for the mesh, as well as a vector to keep track of what the previous start point was. We have this as a private variable for the line size. We can make it a bit more accessible in the future, as far as like changing it on the fly, because that's what Tilt Brush allows you to do. But for now, I just kind of set it as like a private variable. And then the last thing here is this the first quad we've drawn? And so the reason for that variable is, like I said, you need 2 points so that you can actually know what the start and end are. And so the very first time you sample, you only get 1 point. So we just have a Boolean to check, is this the first point we've drawn? And then we do some slight variations to figure out, just to like delay until we get to the second point. So that is what each of those variables are keeping track of. Live, yeah, I know exactly. That's the beauty of Tilt Brush. So so as far as, so this is our start method, and we use that to basically instantiate some variables here. So ML, which is our mesh, and yeah, sorry for the naming. The naming actually came from that code base that I talked about a little earlier, and I didn't bother to change them when I was developing this. So ML is getting the mesh, and that comes from a mesh filter that we will actually have to, when we go back to the manager, we're going to have to change the mesh, or change that code to add a mesh filter and mesh render to it. So mesh filter basically keeps track of our mesh, and the get component mesh renderer is what visualizes that mesh for us. So there's the mesh renderer, and we're going to go ahead and set the material. So we'll get to the material in a little bit, but that basically allows us to change what the mesh looks like from that beautiful pink color, I guess, to something a lot more cooler, and something like the styles that we see in Tilt Brush. So that's the start method. That's just initializing everything. So then we have an add point method, and that's our public variable. So that's exactly the same as the set position here. I chose for simplicity, instead of doing the index stuff, since we're continuously building a line, I chose to actually make it so that you just give us a point and that's the next point in the line that you're drawing. So just keeping things very simple. There's our make quad. So this is the one that's actually when I draw those 2 points. So we have our start and end, as well as what was W here. So W is, I believe, the width of the line, and Boolean all. That's again for like whether this is the first quad we drew or is it subsequent quads. So that's kind of what make quad is doing, is just like given those 2 points, getting those 4 vertices, and then we have add line, and then this is actually building up our mesh as we go. And we have a few methods here to basically resize our arrays that are keeping track of the vertices, UV mapping, which I guess I didn't talk about, but I should talk about, and then the triangles. So going back up here, so add point is really simple. All it's doing is it checks to make sure our start is not at 0, which is basically telling us we haven't drawn anything, which we honestly could just set to, instead of this, I used this from the previous code base, but we could actually change it to first quad. It would work just the same, and probably be it would probably be a little better to do. I'm going to actually do that right now. Change that to first quad. So first quad, we're going to add a line. So that's going to be we give the mesh and the quad and then the quad, and then we just set first quad to false because we've added our first quad. And then every single time we make sure after we've drawn the line that the start point is now whatever point that we just added. Once we do that, so the next method that gets called is make quad. And what make quad is doing is given that start, end, and width and all, we set the width to be half, which is basically saying we want half on the top, half on the bottom of that actual width. Then we have our vector 3 here, which is going to be our list of the quads, which then gets returned at the end. And what we're saying here is if we want all 4 vertices, then we're going to set the size of the quads we return to 4, otherwise we're going to set it to 2. And so the reason for that is it's again coming down to the first quad that you draw. So if you drew these first 2 quads with these 2 points, you want to draw all 4, but then the next subsequent point you add, you actually only need to add 2 vertices because you've already added 2 vertices for the previous quad that you drew. So it's again checking for just the very first time. We get the normal by taking, just like I said, we take the cross product of the start vector and then the end vector. So that creates our plane between these two, and then we just take the cross product that comes out at us. And then for the line that we actually want to draw, so then going back perpendicular to wherever, sorry, I guess it goes this way. So if our plane is this way, the normal is out this way, and then perpendicular to the velocity and the normal is where we're actually going to draw the line up and down. So we get that line, normalize it just to make sure, although a cross product won't be normalized, so we have to make sure it's normalized. And once we do that, it's just defining exactly what those vertex points are. So start, start point, Brian, what's up? And yeah, so then we just get the start point, end point, define where those points are based on the line and the width that we want. And we do that the same for either case, and then we just return that. So that's just creating our quad. And then the last thing, and this is where the bulk of the code is, and I really should have, what I really should have done is gone ahead and factorized this code. Kind of grew to quite a mess. But yeah, so this is adding a line. So this is the add point method's bulk of the work. So we get the quad, we get the mesh, and we check how many vertices we have. We save that list of vertices, and then we go ahead and resize it to add however many vertices we want more. So in this case, it is the 4 points, and then we want to duplicate those because we want it for the front and back. So then we just go ahead and add them with this for loop. And then, so talking about UV mapping. So UV mapping, what's I guess the best way of describing this? So the best way of describing this is for when you get a, if you want to like paint a line, um, you basically the way you do that is you create an image, and it might become a bit more clear when I actually have an example to show you guys in just a bit when we actually go ahead and create a material. But and yeah, I'll probably explain that after the break. But like once we have a basic material for each vertex, you assign on that whatever image you're providing, what point on the for each vertex you provide what point on that image you want to sample from, and then it'll Unity in the background will actually go ahead and interpolate where exactly you want to place those points from that image. So that's basically what this is doing. So like, since we're drawing a quad, we're basically saying the bottom corner is 0, 0. The what did I say? I think I said the bottom right is 0, 1. Top right is 1, 0, and then topmost to the top right is 1, 1. So those just index our image for each quad that we build up. So that's what the UV stuff is doing here. We're just assigning those 0, 0, 0, 1, 1, 0, and 1, 1 values to the line that we draw. And then this is actually drawing our triangle. So the way that this works is, so we want to draw 4 triangles. So because the quad is, so the front-facing quad is built of 2 triangles, the back-facing quad is built of 2 triangles. And so for each triangle, we basically give the index of the vertex that we want to draw. So that's exactly what this custom code here is doing. So for this one, I'm going to go ahead and so front facing quad, and then just comment this back facing quad. So these you have to make sure that you give a multiple of 3 to the number of triangles. So this is the first quad, and it's just basically taking the bottom left point, the bottom right point, and then the top left point, and defining that as a triangle. And then this one does it for the complementary one, and then these two use the copied vertices, and then do it for the back, but in a flipped order. So order is actually very important in the way that the triangles are read and then faced out. So you'll notice, so 5 corresponds to the top right vertex. So like if I draw, that's the best way of describing it. So if I draw this way, so starting in the bottom left and going up to the top, that will face, so I guess that is counterclockwise. Yeah, so if you draw counterclockwise, it'll be facing towards us in the same normal that we provide. If we drew it clockwise, it's going to be facing away from the normal that we want. So that's why these numbers are flipped. And once we do that, we just reassign our vertices, our UVs, our triangles to the mesh, calculate the boundaries, which will be important for adding colliders later, and then recalculate our normals based on the new vertices that we add. So that, in summary, is what is going on. It's a lot to take in, I know, which is why I didn't want to rewrite all of this code from scratch. But that basically allows us to create a line renderer in a way that actually doesn't billboard. So yeah, I'm actually gonna leave that here for right now, and I think, yeah, we're about an hour in. I'm gonna take a quick 5-10 minute break. Let you guys think over that, come up with any questions if you have any, and um, yeah, again, like any questions at all, doesn't really matter what it is. And I'm actually gonna go in and jump into Sculptor VR. So yeah, there we go. For this break, I'm going to go ahead and move that over here. Cool. And the reason I'm going into Sculptor VR, sweet. Glad it's helpful, Tristan. And so the reason I'm going to Sculptor VR as opposed to Tilt Brush is because there are some features in here I want to point out that I think are really valuable. Really valuable as far as like developing. So let's see. My controllers get turned off. There we go. Cool. So very similar to Tilt Brush. This is a voxel-based engine, and the voxel-based, I forgot what the controls are. Oh, there's that. Voxel-based. Wait, what is the? Wait, how do I change? Okay, there we go. This was backwards last time I did. Well, it's voxel-based basically is the whole 3D space is kind of discretized into cubes. This is effectively what a voxel kind of is, like kind of cubes like this. This is a giant cube, but we can change the size of it to be like super tiny, super giant, or anywhere in the middle. I think that's, so I'm going to bring that up close to me, but that's probably the size of the smallest physical space, or maybe one of these cubes. I'm not really sure which is this. Yeah, I guess it has to be whatever is the smallest thing that I can create. And yeah, so that basically defines our space, and we can also add a bunch of different objects in the scene. So like when as you can see here, like even though it looks like a sphere here, it kind of comes out as like a little boxy looking mess of a ball. So I can draw just like in Tilt Brush, but again, in a very grid-like fashion. I can also change the color, just like in Tilt Brush. I can erase, I think. Yeah, there we go. I can erase. But I think the neat part that I found with this, that Tilt Brush, I mean, one of the reasons we're creating custom ones is that we can actually add features that we want that we think that are missing. But the thing that, oh yeah, you can also add rockets, which I thought was really cool. Bye bye. Oh yeah, you can destroy stuff too. I didn't even realize that. Yeah. Maybe I'm not gonna go too fun with this. Sweet. Let's see. Yeah, we're not start. But yeah, I'm distracted. The reason like one of the things I really like about what they do here, and actually let me go ahead and first load up a demo scene. So that things baseline. Let's go to Giza. I don't know what's in Giza. Nice. There we are. So this one didn't have that much. I want something with a lot of stuff. A section tree. What does that look like? Whoa. That is a lot of stuff. And yeah, it is very inception-y also. Cool. So yeah, the reason I wanted to go in here is they have this really awesome teleport feature that allows you to basically teleport anywhere in a scene. So I think, yeah, there we go. You just kind of place it in your scene and you move to that direction because you can only get so far like walking. Like I don't think you see the boundary. Can you see the boundary? No, you don't. You don't see the boundary here, but I do have like obviously my physical space of where I can walk. But this allows me to actually like walk around and build something really cool like this. And I think the even cooler part is I can set the size that I am. So I can be gigantic. If we want to go there, I can be gigantic and look at this tree. I can also, just by changing the view on the touchpad, I can make myself super tiny and then put myself next to this tree. And I honestly like this. I've said this probably a bunch already, but I'm gonna keep saying it because I think it's the thing that I absolutely love about VR, and it's the thing that people don't understand. Like, it's honestly the reason why people don't understand VR until they try it out. It's because of scale. Scale is like the thing that makes VR VR. You can play around with scale. You can like do a whole bunch of stuff that you can't do with a 2D screen, and it really gives you a sense of perspective about everything in a virtual world, and that's like the part that's really amazing. I can also just like jump all the way up here, jump over there, which is actually weird. If you've tried Windlands before, this kind of has that feel of Windlands where I'm like just kind of pull myself, but like instantly teleporting. So I can go all the way to the top, all the way up here. Where's that tree that I saw before? Lost sight of it. So over there. And yeah, you get this lovely sense of height, which is so cool. And the one thing I don't like about the Vive, and I always do this during development, is I walk around and then I take a step back and pull on my cable. And one of these days we're going to get to the point where we don't have to have a cable to experience something amazing like this. But hell, wait, can I walk off? So I don't think. I guess I have space. No, let's see if I walk off, what happens? No, okay, they actually make it so that I can't walk off. Fine. Sometimes I'm a little needy. But let's see. We can also, I guess, destroy this, right? If I send my little rocket off into space. Actually, I want to make myself huge first. And I feel like that will also affect the size of the rocket. Boom. All right, I'm gigantic now. Let's make a rocket huge as well. And oh god, so much smoke in my face. What? Wait, I don't see what's happening. Where did it go? Well, that wasn't as exciting as I thought it was going to be. Just funnel a bunch of rockets all over the place. See what happens. Oh wait, I just totally destroyed my rock, my own rock. That's awkward. Oh, this is so cool. Just to be like, wow, this is, yeah. I hadn't played around with this that much before, but like this is actually really cool. I have no idea if I was on camera or not. But yeah, that's Sculptor VR. There are a bunch of like cool stuff in here that Tilt Brush doesn't provide, and I think would be really cool to see in Tilt Brush. So I'm excited. Like, if people want to see more about like this Tilt Brush creation, I'm like super excited to like build something like this out a lot more. Yeah, that is Sculptor VR. I'll go ahead and close that. So it's nice and meaty. Cool. And of course it's not closing now. Close. There we go. Cool. So looks like we're cool there. So yeah, there are. How are we doing on time? 11:04. That was a good amount of time. Sweet. So we left off with the graphics line render, if I remember correctly. So yeah, if there aren't any other questions, I think I'm just gonna hop back into this for another hour. But yeah, again, keep asking questions. That's like whether it's directed at me or directed at anyone else or directed at projects. Like that's kind of what I want these streams to be. Is like more than just a class. Like talking with each other, I think is really cool, and that's like the part I love about the VR community. So yeah, so we have the graphics line renderer. I'm actually going to go ahead and we're going to go to our draw line manager. Actually, I don't need that anymore. We're going to go to the draw line manager, and instead of the line render, we're not going to go ahead and change that to the graphics, not graphics. Why can't I type? Graphics line render. There we go. So we're adding that instead. Like I said before, we need to make sure we add a mesh render. We need to add a mesh filter and a mesh render. We can get rid of the cur line because then it'll get angry at us for assigning to the wrong variable. So we added mesh filter, mesh render. I'm actually it's easy enough. Let me just go ahead and add a quick method here called set width. And we're going to say float width. Also, if you're coming from a more formal programming background, a lot of people tend to ask me like why use floats, and the reason is it's more for efficiency in graphics. Like you want to just be working with smaller numbers, even if they're slightly less. Well, they're generally like precise enough. As I mean, I'm saying like floats compared to doubles. They're generally precise enough, and it just saves on computation if you're working with floats as opposed to doubles. So we can actually now go ahead and instead of we just want to pass one variable here. We just gotta make sure this is instead of a line renderer, it's a graphics line renderer. We can get rid of that, and then we can say cur line dot add point, same point as before, dot position. Cool. So yeah, that's the point, and let's try that out. So hopefully, assuming I didn't mess up anything, it should look exactly the same. Here's the controller. I want to close that. Nope, wrong controller. Am I drawing anything? Alright, let's see if there are no errors. These are attached. I think I might actually have to provide it with a material. That might be why it's not showing up. So it's either that or actually that one change I made here. Let me make sure that this wasn't the issue. Here, but which one is the right controller? The one. Okay, that was the issue. Wait, why was that the issue? Oh, sorry. Yeah. So this should actually be if not first quad. Should be if not first quad. No. Wait, now I'm confused. So this is saying we need to add a line. Oh yeah, I guess we would need another variable for that because otherwise it doesn't get set. So it's saying, oh wait, does it get set? No, I'm confused. Oh wait, oh the first quad happens at a different time. That's why. yeah, first quad is actually, yeah, it's happening at the third update, or the third add point. We want this to happen actually at the second, once we get 2 points. I think that is why that line didn't work. But yeah, so now it actually does what we want. And yep, we can draw, which is cool. Can paint, and oh yeah, I guess the thing we should check before I get into materials is that it's doing exactly what we want. So if I draw these 2 lines, so like when I was drawing here, the normal is facing up. I can look underneath, and then I see the bottom and the top. We get the normals are facing exactly out from the direction I'm moving my hand. Same with this guy. And draw there. Write my name. It's all in this beautiful pink that we want to change, because that's probably more than just drawing it of itself. This tilt brush provides you with a bunch of different options for exploring the way you express yourself. So let's do that. So I believe, yeah, perfect. So I'm gonna go ahead, create a folder for textures. So Abdel created a couple of textures here. I'm just gonna go ahead and drag in. So if you have questions as far as like how to create these types of textures, shoot them out in the chat, and Abdel can help out with that. Show the mesh as a wireframe. I can show that probably within the editor somewhere. Yeah. So let's go ahead and do that, so that you guys can actually see. Oh yeah. Okay, so in the game view you can't see it, but maximize this. So that is the mesh and wireframe. So pretty much exactly how I built it up in Tilt Brush. So you see, rotate around it, and then you actually see these quads that are basically making it up. And yeah, you can, yeah. I'll like pause here just in case you have any follow-up questions to that. While I reset that back down. Yeah, the game view will show it as the actual thing. What is shaded? Oh yeah, I can also, yeah, that's what it looks like shaded as well. Yeah, we'll switch back. Yeah. So yeah, let me know if you have any questions about as far as like what the wireframe shows. Yeah, cool. So as far as material was concerned, I'm gonna go ahead and create material. There it is. Let's call this wood mat. And for the wood mat, I'm gonna go, keep that in the inspector. And so for the wood mat, we're gonna go ahead and drag each of these things into its appropriate spot. So wood 1 is the main texture. So we're going to drag that into the albedo. This the wood normal here is our normal map. So we're going to go ahead and drag that into the normal map. I guess I can point that out now. I'll show you how to do it manually, although you can just hit the Fix Now button. If you go here and click on the actual texture, it wants you to just save it as a normal map. And you can like change a bunch of different parameters as far as like what the texture actually does. I'm just gonna go ahead and hit apply to that. Go back, click on this texture. And so normally for most people, that is, or like for if you're building 2D games or 2D in the sense that you're looking at a monitor, um, or like basically what you'll see in the game view. And unfortunately, this is something you're gonna have to try out for yourselves if you're developing. Um, but if you're building 2D games, you pretty much only need the albedo and the normal map. But in VR, you're gonna want something for what's basically called the parallax effect, which is like and I'm not sure if I can describe it that well, but the idea is basically you want a shader that is basically taking account of how the light bounces off per eye, and for that you want to use a parallax shader, and a parallax shader basically needs a height map, um, and unfortunately I'm gonna crank this up to 0.8, but you will, and I'm gonna go ahead and add a quad to the scene. 3D object quad. I'm gonna zoom in to, actually just bring it up to 0, 0, 0, 0. And then I'm going to just drag and drop the material onto here. Oh, I guess the other thing I should do is change the color to like a brownish, somewhere like there. And so yeah, you can definitely see the normal map, but let's see if I go, where did I put the material? If I bring this down, you just, this is at 0, and this is at 0.8. It's really hard to actually see the effect of it, but when I go into VR, so it requires to sell the normal map in VR, it requires a parallax shader. For normal maps, don't look as good in VR as through a monitor. Yeah, that's exactly right, Brian. They don't, but for a parallax shader, you do need to provide a normal map. So if we actually go to the legacy shader, so there's the parallax diffuse here, which is basically creating a parallax shader, or you provide the texture, you have to provide a normal map, and then you have to provide a height map. And so all three of these basically create the effect of parallax. And that parallax shader is, you get the real effect out of it in the height map. So yeah, I mean, I don't, when we were playing around with this yesterday, to actually create these, why is it super far away from me? Let's go ahead and move this back to 0 so that I don't have to move this far. There we are. So right now, let me move this up so that I'm still within camera. Let's move you up, move you back a little bit. Maybe I'll move you a little down. Something around there. So now, what is this set to? This should be set to. I'm going to move close to it. I don't actually see it right now. Huh. I thought I saw it last time. What's this look like now? Oh yeah, yeah, you definitely notice it. Yeah. So like, this is like one of the things you really just gotta try out in VR itself. So if you have a Vive or Oculus, it's definitely, you gotta play around with it. But because you don't see it in the, or as I don't see it when I'm in the game view and looking at it in the 2D monitor. I only really notice the effects once I actually put it in VR. It's just the way it renders it to each eye and affects the lighting. And yeah, again, one of those things that like makes it so hard to sell VR to people, but still like important when you're developing. But I think I'm just gonna switch this back to a standard one. I think I saw it better with a standard one. Yeah, no. something like the normal diffuse, I don't think uses the lighting that well. If you switch it to standard and then add that height map in, you really get a strong parallax effect, which is, yeah, you just got to try it. That's the thing when doing VR development. And yeah, that's all I can say, and it sucks because I want to show it, but I can't. So yeah, so that's the parallax shader, and I'm gonna go ahead and tweak our manager here to have access to a material. Let's call it it's a material. Let's call it LMAT, just like it was in the line renderer, and all we have to do is just really set that material. So when we create the object, we're going to go ahead and do curline.lmat equals lmat. That's just going to set the material. So now, assuming, oh wait, no. One thing I have to remember is to actually set that within the editor. So here, I'm just gonna drag our wood material onto there and throw the headset on. Have the controllers, and yeah, so there we go. Now it's actually drawing with the material we want. When I have wood, you can definitely tell, at least in VR, that there's a height map. So it's associated with it because it is kind of wobbly, just like the height map indicates in the editor, and we can just keep drawing, drawing, and drawing, and drawing. And so yeah, that's the basics of getting basic drawing in here. So then the other thing, that's the next step, is really then going ahead and actually changing some of the properties on some of these materials and basically adding an interface. So if you saw my deep dive video that I put out on Wednesday, kind of talked about the way that hand controllers really enable you to interact with the world in ways that are significantly better than just using your head. So put that controller down, and so yeah, we're gonna see if we can add a basic color picker in right now. Why is it still called a graphics? Oh, I can change the name. Like I said, it was based on the graphics library in Unity. So let's see if I can pull that up. Assuming, yeah, there we go. Pull that over. Unity graphics. So if we go in here, no, this one. So it's a library called graphics, and what I was doing before is you actually call draw mesh to actually draw it every frame. I decided I just kind of decided to choose and make it a mesh renderer instead, since we were already building a mesh from scratch. But the code I was using before was using this way as a way to draw it. But yeah, we can honestly just change the name really. That's actually not that hard to do. I'm gonna press F2 to rename it, and then we can just call it, let's say, mesh line renderer. Change the name here to mesh line renderer, and then just make sure those are named appropriately. And yeah, now it's actually what it's, I guess, named to be. So that's that part. So so for setting the color, I'm gonna actually go ahead and go back into the asset store, and I'm gonna go ahead and get a simple color picker. So this is a free asset that has a color picker and 3D space, which is exactly what we want. Thanks, Simon. Appreciate it. um, and so yeah, so that is a simple color picker. We can go ahead and import that. Again, there'll be a download link if you haven't. So this is built. What was it built for? Unity 4? Oh yeah, it was built for Unity 4. It says right there. But it works with Unity 5. You just have to click I made a backup, which I didn't because I know it doesn't mess up with anything. One thing I don't like is that they didn't put it within their own color picker folder. That's one of my biggest complaints. If you're actually submitting something to the asset folder or to the asset store, please go ahead and just refactor your code a little bit and drag your assets into a top level folder so that when you import it, it isn't a nightmare. Saves a lot of people time and effort. So yeah, the materials need to go into simple color, example into simple color, readme into simple color, shader, yeah, shader into simple color. I think that's it. Yeah, that's it. Sweet. So now everything's in here so that at least the top level is cleaner. Let's go ahead, save this. Oh, I guess I've never actually saved the scene. What do I want to call this? Drawing in space. Cool. So now we have that scene. So we can always go back to it because it's now an actual file in our file system. Let's see, where are we? Sweet. So let's just play around with quickly what they've done first. Basically, so if I'm moving around in the scene view, I can see that they have the color picker in 3D space. This is on the right is their, that can't be right. It's not 0, 0. There we go, that's better. I guess it wasn't initialized at the beginning. You can move this, they call it a thumb, I believe. Right, yeah. It's this guy. Yep, so they call it a thumb, and that allows you to pick the saturation level. So if you want it white versus black or anywhere in the middle, you can do that. If you want to change the color, you have this wheel here at the top that basically changes the color for you. And yeah, very simple color picker in 3D space. Of course, they've implemented it for using a mouse. Because we're VR developers, we purposely choose not to develop with a mouse because it sucks as a VR input device. And luckily we have Steam controllers. So we're going to change their draggable method to basically be able to do that. So I'm going to go ahead and open up that script. And so draggable is pretty much, I think, the only thing we need to change. And this is where they do all their input. So just like we did, let me open up the line manager. So exactly like we did here, I'm gonna bring that in, and everything is gonna be based on the trigger. So we want again, we're gonna have a public SteamVR tracked controller. Call it tracked obj. Done. Oh wait, tracked object. Sorry, not tracked controller. Yeah, their naming I feel like needs to be done better, but that's fine. So tracked object and same deal. So instead of the button, we want to use a trigger. So we're going to use get touchdown for the get mouse button down. Just delete that. We're going to change this actually. So that variable there is telling it how far. It's an optimization for the math to like basically go only 100 units away. We're actually going to change that to infinite because scale will be important soon, and I just want to change that now before I forget. So we can copy this. So this one is a get bounce button up. Get touch up is the method we're going to use there, and we're going to copy you, and we're going to make this just get touch. So that's this. So now it should take care of, like, as far as getting the trigger input. That's pretty much done. The one thing that we have to pay attention to is how they're how they're actually doing the selection. So the way they do that is they're taking where the camera's looking, and this is all designed again for like a 2D interface. So they're taking where this camera's looking and then doing a screen point array. We can't do this because we're actually using the controller as our point of location. So what we're going to do instead is going to go ahead and create an array, call it new array, and it's going to start from our tracked object transform.position, and it's going to go. And so yeah, here are the variables that we use for the constructor. So it's the origin, which is from the controller, and that from the controller it's going in the direction which is wherever actually the device is looking. So we're going to go ahead and go to tracked object dot transform dot I don't think there's there's a forward. Perfect. Awesome. So we're going to go ahead and use that and then comment out their array. And so yeah, as far as like doing the raycast, that's all we need to do. For doing the dragging equals false, that's fine. We don't need to worry about that. For this, they actually choose not to do a raycast, but we want to do a raycast. So I'm gonna actually just go ahead and copy this. And so we're going to do a raycast, and then we're going to actually copy all of this code in here, paste it within the if of like if we actually are still still touching the object we want to hit. Get rid of that. That's the raycast, and now they have the var point, which is I believe, yeah, it's a 3D position. So we're gonna, instead of that, we're going to go to hit dot point. Good naming convention. So that's the actual point in 3D space that we hit. And then everything else should be fine. I think that's all of the changes we need to make. So yeah, let's go ahead and try that. Let's go back to our original scene. And I'm going to move you not that way, this way, not that way, not what? Wait, what? What directions are these going? I guess this way. There we go. I'm just gonna move it a little back because the color picker is huge. And then simple colors. I'm going to drag that in, and yeah, like I said, massive. Let's see, I want to move this over here. Yeah, perfect. I'm just gonna move that over here, and we just have to make sure that on our draggable objects we provide the right controller. So what did I use? I used the right controller for drawing, so we're going to use the left controller for dragging, or for selecting color. So I'm just going to make sure I drag left controller into both of those. and let's try it. So, turn my controllers on. There's this dude. Oh, there we go. Oh, wait. Where's my right controller? It is missing. Why is my right controller missing? It's here, but not. Did I change something to the right controller? SteamVR controller. Oh, that's not what I wanted in the color picker. When did you get added on? Oh wait, no, that's. Let's see. Are you here? Okay. Yeah, I don't know why it wasn't tracking both before. Strange. But yeah, now we have it. This is behind us, so just to make sure. Yep, we can still draw with our right controller, and yep, I can now change the color with my left controller. But you'll see it's actually a little difficult for me to actually aim, especially at the top one. This one's kind of easy, but there we go, kind of. So we're gonna fix that, make that really simple because Steam provides us with a raycaster as far as allows us to draw a line of sight. So if we go into, how are we doing on time? We're doing pretty good. Here, there's a teleporter, there's a laser pointer, gaze tracker, track controller. We want the laser pointer. So we're just gonna drag that onto there. We can change the color. I'm just gonna make it a red, change the thickness, and a bunch of different parameters that I don't think we care about. And yep, there we go. Got a nice red laser pointer on our controller. So let's see if that makes it a lot easier to aim. Exactly where we want it. And yeah, there we go. Change the color there. Yellow, white. Cool. So yeah, that is picking the color in 3D space with this controller. And yeah, the only thing now is to just make it so that it actually changes the color of whatever object we're painting with. Obviously, like for the wood, it kind of only makes sense to have brown, but we're going to play with what we have anyways and then make that work. So let's see, we are, where are we? So there we go. So let's go ahead and go to simple color script, leave. Yeah, there we go. I have example color, color receiver. So the way everything in their simple color picker works is they have they use send messages, which honestly I don't really recommend. I recommend using C# events and delegates. It's a lot cleaner. But this is all you really have to do is make sure this script is, I think, on the color picker, and then you'll receive the on color change method. Painted wood does exist in Tilt Brush. Cool. Well, I guess that's what we're making. So yeah, so we're just gonna go ahead and do exactly that. I'm thinking, let's just go ahead and create our own script. That way we're just not touching the example. Receive, or let's just call color manager. Open that up, and it's like a little. I'm going to be doing. Just copy that part of it into here. Go ahead and make this private. And we're going to be doing something I like to call, or I don't like to call it. It's called, I believe, singletons is I think the formal term for it. But basically, what we're going to declare here, instance. What we're declaring here is that this color manager, there's going to be only one that exists in our scene or at any given point in time. Oh, in reality. Yeah, I guess that's true. It does exist in reality. Color manager instance, and then awake. So on awake, what we're going to do is we're going to say if instance equals null, which basically says there are no instances in existence. We're going to make this specific one that's awakening our instance. And we're going to do the reverse on destroy. We're just going to say if instance equals this, instance equals null. It's just the reverse. What that allows us to do is have a public variable here called public void, public color get current color and return this dot color. So that'll just go ahead and return the whatever color that we have saved here. So that's the on color change, and we just have to make sure on the color picker we add color manager here, and then what we have to do is we go to our draw line manager, and what we're gonna do here is if color manager, or actually no, if curline doesn't equal null, what we're gonna go ahead and do is say curline dot lmat dot color equals color manager dot instance dot get current color. So this is going to be running every single time, and if the curl line, as long as the curl line isn't null, we're going to be setting it. So let's try that out and see. Let's see if that works or if that needs to be debugged. And so there's one. All right, there we go. There we go. There we go. So let's go ahead, change this color, I don't know, to bright red, and see. There we go. Change it red. Change it to blue. So now we'll see it actually does change this because that's the current line. So I'm going to go ahead and draw a green one. They actually both change. And so the reason for that is we're actually, I think, not making copies of our material. Actually, wait, is that right? Yeah, I think the reason is we're not making copies of the material. So that's actually, if you're looking in Unity, it's actually changing our wood material, which we don't want to do. So I think instead what we want to do here is instantiate a new material each time. And here I'm just actually, unfortunately, most changes in Unity aren't permanent, but when you're changing assets on the file system, those do remain, which is a little unfortunate with materials. This is black for whatever reason. So now that was the current line, it's now green. Make this bright green. There we go. Now I'm gonna go ahead and draw this guy, make it blue, and yep, now they're two different colors. Of course, if I can now change this color again after I place it. And this is like a design choice that you need to make is, do you, like once you've placed it, do you want to change the color? To be honest, it is a little awkward, so we can actually just, it's a really quick fix to make sure that that doesn't happen. So we're going to go ahead and do that. Let's do that really quickly. All we really have to go is to this draw line manager. We're going to say else if here, and then we're going to put it as touch up. Oops, wrong way. There we go. I'm going to actually go ahead and set the 0 here. And then we just have to make our curl line is set to null. So then it'll never actually go in here as soon as we let go of the trigger. So we can change the color of the whole material if we're still holding it down, but then if we let go, then we don't. So now, yeah, let's just go ahead and test that. I have no idea what color I left off as. So yeah, also, of course, that brown is now permanently staying here because we're not changing the material that's on the file system. So that black, I'm also not sure. Oh, current, so yeah. So I guess the current color is initially set to black. We can change that default. We can add another if check so that we don't get a black. But yeah, now it's black permanently. If I go ahead and draw it, but I haven't, I'm still holding the trigger. I can still go ahead and change the color with my left hand. Make it a blue. Change the color here. Just go ahead and put that. And yeah, so we have that, and now of course change the color again. That now doesn't affect whatever I've drawn. I can go ahead and make it green. I don't know what I'm drawing, but I'm drawing. And yeah, so now that's a green. We can of course, this is actually very different from what tilt brush lets you do. They don't. So well, the way tilt brush will do it is you have to stop drawing in order to change the color. We are avoiding that because I can select with my left hand, and then I can draw with my right hand. So that allows me to change the color on the go, which is a very different concept than what tilt brush lets you do. But still, I think pretty interesting as far as design choice is concerned, because you are, after all, allowed two controllers. But yeah, that's changing the color of some wood. Look at it, the height map is still applied, it looks good. We've got the wood there. The only other thing is we could, I don't actually know if we want to do this, but so the way this laser pointer actually works is it'll collide with the first thing it hits. But these meshes here, but that requires you to have a mesh collider. So for example, this quad has a mesh collider, so I can point at it and I can't really show it to you that well. Yeah, okay, so here you can see that it goes all the way back, and then it doesn't do that once I hit the quad. So that has a mesh collider, but these don't, which is why it like goes straight through. We can add mesh colliders, but I don't know if we necessarily want it right now. That will block you from actually hitting our color picker in the back. But yeah, that's kind of the general gist of how are we doing on time? Yeah, 11:50. Uh, General gist of kind of what I wanted to go over. If you guys have any questions about anything that kind of went over what you would want to see, probably stick around for probably a few more minutes, and then we can wrap this up. But yeah, thanks everyone for watching. And yeah, let me know. Let me know if this was useful for you guys. What you want to see in the future. Um, I'm thinking. I'm thinking of next week going over like how to create a multiplayer um, a scene, like a social scene. If you've not played, if you've gone into Oculus Social on the Gear VR or Converge, something very simple like where we have a scene and you have like two heads floating around that have their rotation tracked. So the whole point of that would be kind of to go take this to the next step where we can get maybe someone in viewing in Google Cardboard while someone's actually painting, which I think that's something that I'd really want to see in Tiltbrush because I think that would be super cool. Um, but yeah, I'll just kind of stick around for a few more minutes here, and yeah, yeah, I guess obviously if you wanna see more of this stuff, just like the video or subscribe. It's recorded afterwards, and I'll also like probably a few hours after YouTube's done processing, I'll go ahead and add some timestamps to the video so that you can go ahead and jump around to like different parts of like where I'm explaining stuff. Hopefully that's helpful. I've done it on the past videos. Not sure if anyone's been using them, but still, go ahead and do that anyways. Yeah, let's stick around here. Let's see, what else would I want to add to this? That's what you showed us to implement this. Could you link the few scripts you copy in the video description? Yeah, I can go ahead and do that. So I guess this one, just small. That's the example that's already out there. This one's tiny, draggable. Where is it? This one. Yeah, I can add this one. Like a Dropbox or Google Drive. Like this is probably the most complicated one up of the bunch. Um, like once you understand like what's going on as far as like creating the quad is concerned, it's not that bad. But yeah, just kind of like getting your head wrapped around it is the tricky part. Yeah, there's that. Yeah, let's stick around 2 more minutes or something. So, see what people want actually. While I do that, why don't we just go? Actually, no, I want to go into Sculptor VR because that one was a lot more fun. Go back into Sculptor. Play all the different demo scene, kind of blow that up because that was fun. More recent demos. I think the one thing I don't like about this is the text is really hard to read. What's in here? Nice. Yeah, this is the one I liked a lot. Let's go ahead and move there. Up here. And let's get those rockets, because those were super fun. Giganto rockets. Also really like the Vive's haptic feedback is like it's so subtle, but it like still makes a huge difference, especially when added properly. I don't think Tiltbrush has it. Obviously, like with these rockets, I can definitely feel it, and like you don't even hear it when you actually have audio in, which is I think the really interesting. interesting part, because like right now, because I don't have headphones in, I can definitely hear the shaking, but yeah, still, I don't know why. It's I didn't notice these rockets that actually kind of were that destructive before, but that's that's the fun part about this. So much fun. Luckily, you can save these scenes. Otherwise, actually, I would kind of feel bad destroying this. But that's the beauty of VR also. Like you can save and do whatever you really want without feeling bad about it. All right, I've had enough fun with that. Yeah, I'm gonna go ahead and wrap this up then. Let's go ahead but yeah, I'll stick around in the chat for a little bit, just to see if anything else pops up. But other than that, yeah, it's been FusedVR. I'm signing out, and yeah, I'll see you guys next week. Yep. So, yep. See you guys.